Hello again. Professor Jared Rathel here. I just wanted to take a couple of minutes and personally introduce myself to you and then talk a little bit about what I call the big ideas, these principles that really guide my teaching philosophy. So, right off the bat, I should probably let you know that I don't have a lot of formal training in education, in pedagogy, for good or for ill. I'm a wildlife ecologist by training. So, I got my bachelor's of science in wildlife and fisheries sciences at Texas A&M University many moons ago. I got my master's degree in wildlife biology from the University of Montana. And then I got my doctorate in wildlife ecology from Utah State University. So I've spent several decades chasing wild animals, researching wild animals, contributing to conservation biology and the management of wildlife. That said, it is April 2025, so I am now finishing up my 18th year of teaching. So hopefully that will assuage some of your fears. I've taught everything from seventh grade science in a small rural school in South Texas to big inner city high schools. I built an AP biology program. I taught at a STEM charter out on Maui. I taught at Utah State University. I currently teach at Arizona State University, an American public university system. And of course, I'm appointed residential faculty here at Estrella Mountain Community College. This is clearly my better half. This is my wife, Dr. Heather Rathel. We got together in 1998, so this is year 27 for us. Heather is a faculty at Arizona State University. She's in their teacher college, so she mentors pre-service teachers. She has decades of experience in education. I put this picture in purposefully for all of the young gentlemen in the class. So I want you to look at that guy's carefree expression. So we're living in Thailand at this point. It's 2008, 2009, and I don't really have a care in the world. The only thing I'm thinking about is what are water conditions going to be like the next day for scuba diving. And then, just like that, boom, everything changes when one bad little mother sucker comes around. So that's my son, Bodhi Ren Rathel. He was born in 2012. And then in 2014, my daughter, Sage Kamala Rathel, was born. So these are my kids. They are the light of my life. And if you are a parent or you understand, this is them from a couple of years ago at Christmas. These are our COVID puppies, Teddy and Bear. They're King Charles Spaniel mixes. So we have a whole menagerie at the house. We have two dogs. We have three cats. We have two guinea pigs. And fortunately, the snake we just rehomed, but lots of life around our house. And now my kids are getting all big. So this was Christmas this past year. My son's about to turn 13, and my daughter just turned 11. So, what guides my teaching philosophy? What keeps me grounded? The number one principle that I try to employ in building courses and interacting with young budding scientists is that science should not be boring. It is so much more than a collection of facts in a textbook, which I'm going to get into in detail in 1.1. But my perspective is that science is the most powerful tool that we have for answering really profound questions like who we are and where did we come from, as well as for solving wicked problems. So it's April 2025. So just a few weeks ago, Colossus Biosciences announced the de-extinction, notice the air quotes, of the dire wolf. So this is Romulus and Remus. So it's a gray wolf genome, and they've inserted a number of dire wolf genes to create these genetically modified organisms, part gray wolf, part dire wolf. The verdict is still out on whether or not these are truly dire wolves. And I'm actually of a split mind. So the science is amazing, and it's going to lead to all kinds of new advancements in genetics, genetic medicine, genetic conservation. But one also has to think about the tens of millions, perhaps the hundreds of millions of dollars that have gone into this work, and think about how much habitat that could have potentially preserved for present day species. So we'll see, if the mammoth and the thylacine and the dodo bird are coming soon to a theater near us. We shall see. But regardless, it's an exciting time to be in science. Second big idea: science is wild, it's weird, it's gross, and that's what makes it beautiful. So I always show this image on the first day of my in-person classes, and to date, no one has ever gotten it. I ask, what are we looking at? And then I usually give some hints. This is taken with a scanning electron microscope, so the scale is quite small. And, most people realize that it's some sort of an appendage. And then they're like, well, is it a part on a bug? And you're close. This actually comes from an arachnid. It's a body part on an arachnid, which includes the spiders, the ticks, and the mites. And then I'm like, well, what body part is it? Somebody inevitably says it's clearly a mouth part. No, it's not a mouth part. No, it's not an antenna. No, it's not a leg. And we start running down the body parts. And then I start to see all these shocked and confused faces, which is really the best part, because they're like, he didn't, he wouldn't. And then I'm like, oh yeah, he did. So that, my friends, if you're not aware, is a bed bug penis. Yes, the bed bug penis is 2/3 the size of the bed bug itself, and it is razor sharp. So the male bed bug is going to chase down the female bed bug, and he is going to pierce her exoskeleton to insert his gametes. So not exactly romantic, right? But that's not the best part. Male bed bugs will take their massive sword penises and they will sword fight, Game of Thrones style. The winning jouster will inject his DNA, his gametes, into the loser. And then when that losing bedbug goes and copulates with other females, he doesn't inject his DNA. He injects the DNA of the winning jouster. Thus, over evolutionary time, there has been strong selection for large, sharp, sword penises in the bedbugs, and for those bedbugs that turn out to be the best jousters. You can't make this stuff up, right? The natural world is just endlessly fascinating with all of these wild, weird, beautiful, gross examples, which I try to highlight throughout this course. Third big idea: science can be your ticket to travel and see this big, beautiful world. So take it from me. Science has been my ticket to work all over the world in some of the most beautiful places. So my parents were middle class. My dad managed restaurants and then sold restaurant equipment. My mom was a middle school social studies teacher. I started working in the fourth grade, throwing newspapers, worked all through high school, worked all through college. Um, but I invested in myself. I invested in my education, and it was the best decision that I've ever made. Let me show you what I mean. My very first wildlife job was with the United States Forest Service. I landed an internship through the Student Conservation Association. And this kid that had grown up in Chicago and Texas suddenly got the opportunity to go and live and work in the Stanislaus National Forest in the Sierra Nevada mountains in California and was simply blown away. My job was to locate northern spotted owl and goshawk nests so that we could create buffer zones around those nests that were safe from logging. So I drive all around the woods in the middle of the night, playing owl calls on a megaphone, trying to get callbacks. Whenever I did get a call back, I would take a bearing with my compass. The next day, I would hike in with live mice in a Tupperware in my backpack. And then when I located an owl, I would place the mouse on a stick and I would go fishing for owls. The owl would swoop down, grab the mouse, and then it would make a beeline for its nest. And then you run and you try to find the owl nest. After that summer, I was hooked. The next summer, I got to go to the National Natural History Museum, the Smithsonian, in Washington, D.C. There, I worked on subfossils, so bones that had been recovered from lava tubes on the Hawaiian Islands from what are called the Moa Nalo. So these were massive flightless ducks. So these were ducks that were like as big as a turkey, and they had evolved flightlessness like birds so often do on islands. And I was looking at their leg bones and their bills and trying to determine if we were looking at different species of Moa Nalo or sexually sized dimorphic species. So incredible summer at the Smithsonian. The next summer, I got a job with Alaska Fish and Game, working on Prince of Wales Island in Southeast Alaska. And I did a lot of vegetation transects, trying to understand how clear cuts that Ronald Reagan mandated in the 1980s were affecting the forests decades later and the Sitka black-tailed deer populations, as well as the wolves. That summer, I got to radio mark my first deer and also do my first radio telemetry flights. And it just further solidified that I wanted to be a wildlife ecologist. After applying to 7 different graduate programs, in 2002, I finally landed a fellowship, a master's position at the University of Montana. Between 2002 and 2005, I spent 3 years radio marking newborn calf elk to try and understand the causes and rates of their mortality. So on the left, you have a newborn calf elk in the Blackfoot Valley, and it's wearing an ear tag transmitter. And then on the right, that's that exact same calf 3 days later after the bear got a hold of it. I have an entire case study built around this work, so I'm not going to get into the details. But for those of you that are into forensics, this really delves into that because it's kind of like what I call a natural history mystery. When you find a carcass, you have to look at all the evidence to try and determine who done it. After the University of Montana, I landed a position with the U.S. Fish and Wildlife Service, where I was the crew leader on the Louisiana black bear repatriation effort. So this involved translocating Louisiana black bears from the Tensas National Wildlife Refuge down to the Atchafalaya River Basin, basically an area where the bears were surrounded by agriculture, moving them to an area where there was good habitat but no bears. How do you catch a bear and her cubs? You have to get them in the dens Where do they den? They den in the middle of swamps up on the top of giant bald cypress trees. So this is like, 500, 800-year old bald cypress tree, over 100 feet tall in the middle of a swamp. And that right there is the tree cavity. So branches break off and the trees rot from the inside, and they make these basically hollows. And the bears climb up these trees and they go into these cavities. Here, you're looking down inside the cavity. You can't really see it, but there is a female bear curled up at the bottom with her cubs. Logistically, it was probably the most dangerous work that I've ever done. We would take a slingshot with a nut hooked to a fishing line on a reel, and then shoot it up over the limb. And then we would tie a rope to that and then reel the rope up. And then we would use ascenders and harnesses to climb the trees. And then once you got up to the top, that's where it kind of got dangerous. You take a headlamp and you look in and see how far down the bear is. And then you have to screw in tree steps into the sides of the tree. Of course, first you got to lean in and dart the bear. So you use an anesthetic and put her to sleep. And then you have to unhook yourself, which is really scary, and then climb down into the tree with the bear. And then you rig the bear up in a harness with a pulley, and some very strong Cajun guys on the bottom would help pull her out and through the hole. And then the cubs would go in a little ice chest. So it was amazing work. Unfortunately, we were shooting film back then, so not digital cameras. So I don't have a ton of pictures, but there's one of the little cubs that we moved. So that spring, we moved 7 females and 11 cubs. So it was an extremely successful spring. One of those females went on to swim the Mississippi River, and she was the first black bear documented in Mississippi in like 40 years. So super cool. So even though I've had a lot of experience chasing these big mammals, my happy place is underwater on scuba. And so I got into scuba diving in South Texas when I was teaching high school down there, and I began volunteering at the Texas State Aquarium, where my wife and I would do the dive shows on the weekends, where you can see me feeding some stingrays. So you got an audience of kids watching. And then on Tuesday nights, it was great. On Full Scuba, we would get into their Islands of Steel exhibit, and we would clean the shark tank. So many stories. So this is Hans. She was a big 7-foot sand tiger shark. This was a grouper that would hang out behind you, and when you pulled out your regulator and blew it a kiss, then it would change colors and swim away happily. On the bottom left, this is Popeye. Popeye was a blind moray eel. Really hard to feed Popeye. So we would take basically a spear and put a fish on the end, and you try and stick the spear with the fish into the moray eel's mouth. Morays have 2 sets of jaws, so one to grab it and pull it down the esophagus. So that was all fine and good. Popeye was blind, so you basically had to force feed this eel. But the hard part were these nurse sharks. So if I remember correctly, there were 5 very large nurse sharks in the tank, and they would try and steal the fish. So I would sit on the bottom of the aquarium and basically play middle linebacker, and these sharks would come in and try and grab the fish, and I would grab the sharks by their pectoral fins and spin them around and push them off of Popeye's food. So a lot of work goes into aquaria and zoos. I've worked at both over the years. From there, we moved to Thailand, and I had the opportunity to serve as the reef check scientist for the country of Thailand. We had secured an Earthwatch grant, and basically we trained teams of volunteers to survey the reefs of the Andaman Sea off the coast of Thailand from Burma all the way down to Phuket. It was an amazing year. This was a whale shark that swam by at arm's length. After Thailand, I went out to Maui, and my wife and I spent a year teaching out there at a little STEM charter. That is Haleakala, the crater, so you can actually hike across the crater. And there's some old cabins down there that were built by the American Conservation Corps, so highly suggest hiking across the Haleakala crater. If you visit Maui, if you visit the Hawaiian Islands, just reach out to me. I know a lot of good spots to check out. But what is your point, Rachel? So I love ecology. I love nature. I love the natural world. It has really brought me an incredible sense of fulfillment and joy and wonder and gratitude. And so I hope to share that with you, and I hope to rekindle some of that inner child that we all carry with us, that inner fascination for the natural world and for other beings. And then, most importantly, the reason why I do what I do is because I believe that the world needs you right now more than ever. I believe that your generation faces probably the greatest choices that we've ever faced as a species. It's unclear to me whether we're going to stabilize the climate or whether we're going to acidify the oceans. It's unclear to me if we're going to be able to conserve tropical rainforests and coral reefs and mangroves and tallgrass prairies and the Sonoran Desert. So there are a lot of big decisions that are coming down to you, and many of the problems you're inheriting from my generation and my parents' generation. And for that, I'm sorry. But with great power comes great responsibility. And so in the end, we will conserve only what we love. We will love only what we understand, and we will understand only what we are taught. I have had some truly remarkable mentors over the years, and I hope to channel some of that down to you in the hopes that you will continue to carry the torch. So that's me. Welcome to Biology 182, and please reach out to me. I really would like to get to know you this semester. Thank you for your time. Cheers.